Okay, so here we go. This is empirical formulas. This is something we did not talk about in advanced chemistry, so this is one of the new topics that we are talking about. And this one might take a little figuring out, so I might recommend going back through this video again, and we'll definitely see some practice on this because I know it's something that you have not seen before. So, empirical formulas. Here we go. First question, what are empirical formulas, right? Great question, which I have a great answer for. Empirical formulas are chemical formulas that tell the relative amounts, or ratios, if you would rather be very mathematic about it, of elements in a compound rather than exact amounts like a molecular formula. So if we look at an example here, right, we've got our molecular formula, C2H6, we've got another one, C3H9, and another one, C4H12. Now, while all of these are clearly different molecular formulas and are the formulas for multiple organic molecules, they all have the same empirical formula, CH3. Because all of these have ratios of 1 to 3, right? 1 to 3, 1 to 3. So that is an empirical formula, right? It shows the ratio of your elements rather than the specific number of elements in a formula, right? So that's what an empirical formula is. Now, there are some ways to calculate things about empirical formulas and or using empirical formulas. And one of those is using empirical mass and molecular mass to calculate a whole number multiplier that you will use to take an empirical formula to a molecular formula, right? So we're going to use molecular mass and empirical mass right, like molecular mass, is just the mass of all the atoms in that formula added up, right? So for empirical mass, instead of using the molecular mass, right, you're just going to use the empirical formula. So, right, empirical mass, the mass of all the elements in the empirical formula added up. Molecular mass, the mass of all the elements in a molecular formula added up. So let's take a question here. A molecule with the empirical formula CH2O is experimentally determined to have a molecular mass of 180 grams per mole. So then we ask the question, what is the molecular formula, right? We know the empirical formula, we know the molecular mass. What's the molecular formula? How we go about that, right? We're going to calculate our empirical mass, right? So we take this formula and break it down. So we have 1 carbon, which if you look on your periodic table, has a mass of 12 grams per mole. We have 2 hydrogens, which again, periodic table, essentially 1 gram per mole. And we have 1 oxygen, periodic table tells us pretty much 16 grams per mole. So when we do this math here, right, we do a little math, we find that our empirical mass is 30 grams per mole. Now we're going to use this formula up here, and we're going to say, well, our molecular mass, 180 grams per mole, our empirical mass, 30 grams per mole, and we get this answer of 6, right? And so that is going to be our whole number multiplier by which we are going to multiply the empirical formula to find the molecular formula, just like this. And so when we multiply all these subscripts through by 6, we get C6H12O6, which hopefully is a familiar formula to you all, because this is glucose. All those great memories of biology flooding back to you as we say the name glucose. Okay, so that's using empirical mass and molecular mass to calculate a whole number multiplier to figure out the molecular formula. Okay, now here's another type of question that you will come across a lot with empirical formula: calculating the empirical formula from experimental data. This one has a lot of steps, so get ready to pause the video and write down each step. All right, this is something you're going to want to write down, so pause the video, write down each step. So the question here: vitamin C contains 40.92% carbon, 4.58% hydrogen, and 54.50% oxygen by mass. What is the empirical formula? I'm sure this is exactly what all of you wanted to know. So the first step for doing this calculation: assume that there is 100 grams of the substance. So why we do this is because this allows us to use the percentages as the mass for each element present, right? Because if the total mass is 100 grams, then 40.92 grams of that is carbon, 4.58 grams is hydrogen, and 54.50 grams is oxygen of that 100 grams of the substance. This makes things a lot easier, so we just always assume that there's 100 grams of the substance. So that's step number one. Step number two, we're going to calculate the number of moles for each element. So that really simple calculation, if you remember from our dimensional analysis and stoichiometry, we just divide the mass that's there by the molecular mass, and we convert it to moles. Now, we're going to want to look here and find the smallest number of moles, 3.406. Because that's going to be important for our next step. Just get rid of these. Okay. Because our next step is divide each of the number of moles by the smallest number of moles and determine a multiplier that will result in a whole number ratio for all elements. So pause the video, write that down, read it, and we'll see how this works. So first step, divide each number of moles by the smallest number of moles, right? So we take each of the moles and we divide them by 3.406, right? We're going to get some answer. In this case, we get 1, 1.33, and 1. Right? Now we have to determine a multiplier that will result in a whole number ratio for all these elements. Hopefully all of you can see that 3 is going to be that number. And when we multiply through by 3, right, we get 3 times 1, which is 3, 3 times 1.33, which rounds up to 4, and 3 times 1, which is 3. And these numbers here are going to be our subscripts in our molecular formula. And our molecular formula, right, because the empirical is CHO, we have C3H4O3. And there we go, molecular formula, vitamin C. Okay. Not terribly long video, but there's a lot in there. Like I said, make sure you have paused and written down the steps, because those, while they sound simple, sometimes are difficult to remember. And that's empirical formula. I'll see you in class.